Good morning, everyone. We will start with our first section. Now, I would like to welcome Dr. Ruben Sudhakar, Assistant Professor of Department of Energy and Environment, to invite our first guest for the section.
Thank you, Meenakshi. Good morning once again to all the participants who have joined this program. I consider this a privilege today to introduce my guru, Professor Ajit Kumar Kola. Professor Ajit Kumar Kola has introduced me to research and has introduced me to so many good things. So I indeed consider this a privilege introducing him to the set of participants of this FDP program. Professor Ajit Kumar Kola earned his PhD from the Mechanical Department of IIT Madras in 1977 and did his postdoc in Department of Energy Engineering, University of Illinois, Chicago, and moved on to be a research assistant professor, Newark University during 1979 to 1982, and then joined IIT Madras as a faculty member, and then continued till 2014 as a professor over there. He has worked a lot in different areas of energy. To name a few, he has worked on fluidized bed heat transfer and combustion, advanced coal technologies, Fourier analysis of coal-based power plants and cycles with CO2 capture, fuel cells, biomass combustion gasification technologies, life cycle analysis based sustainability analysis of energy systems, and so on. In last 5 years, even after his retirement, Professor Kolar had been very active, taking up several responsibilities in the field of energy and environment. He had been a TIFAC DST delegate to Paris COP21 in 2015. He was a member TIFAC Committee on Energy during the period 2011 to 2017, and he has contributed to the report prepared by UNFCCC BUR2 in 2018. And he is a contributor and co-editor to Energy Technology Vision 2035, produced by TIFAC. This is yet to be released. And he is an invited member of GTWG on Advanced Coal Technologies DST during the period 2014 and 2018. And he was also an energy coordinator, playing a very active role in Indo-German Center for Sustainability, IIT Madras, during the period 2010 to 2014. Even today, he gives lectures all over the country in different institutions and organizations on various aspects of energy, in particular the sustainability aspects. Even today, he is working with many research scholars on sustainability front, on energy technologies. Sir, indeed, it's a privilege to have you with us on this FDP. Looking forward to hear from you. I'm sure all the participants are going to gain a lot from your lecture, sir. The floor is yours, sir, please. Thank you.
Good morning to all of you. First of all, I would like to thank Dr. Sudhakar for his very kind words of introduction. Also, I would like to thank Dr. Kanagave and Dr. Swaminathan for remembering me after such a long time. It is so nice to hear from them. Also, thanks to Dr. Premalata for having invited me for this program. The title of the talk is The Role of Biomass in the Future Sustainable Energy Mix. Dr. Kanagabel has given an excellent overall view of the energy scenario. It gives a very nice picture of global and Indian energy situation. So that makes my task, as usual, it happens a little bit easier, but I will also try to give some statistics from my point of view. So I would like to thank all participants in this workshop. I'd like to thank the organizing committee for giving me this opportunity. Thanks to Professor Premalata, Head, Department of Energy and Environment, for her support and cooperation. And Dr. Ruben Sudhakar, who has been a great assistance to me in planning this lecture. The content is introduction, Indian energy scenario, As I said, Dr. Kanagavel has given quite a bit of information, very interesting. Biomass, I'll talk briefly about this because there are a lot of experts who are going to talk about technology, specific technology. Then sustainable energy mix. So I'll talk about a little bit about sustainability, not only technically, but my association with other experts in this area and international exposure. Um, I attended the COP21 Paris Climate Accord as a type PhD type fact delegate. Interacted with scientists there, and I gave a couple of talks. That has changed quite a bit of my perception about sustainability. So some personal views I'll be giving to you, which I think are important. That's what I'll try to do. And then we'll end the talk with my final remarks. Sudhakar, what is the time frame for me, please?
Sir, you can take 1 hour 15 minutes from now on, sir. Something like 11:45 should be good enough.
Okay, thank you. Thank you. So, briefly, to bring out the importance of biomass, the basic needs of all of us is, earlier we used to say food, clothing, and shelter, but we should add energy right in the beginning. Without energy, especially bioenergy, we cannot live at all. So energy is extremely important, basic need. And till the 1800s, biomass was the main fuel, as all of us know, all over the world. Coal, oil, natural gas, which are fossil fuels, they gained prominence only after 1850. The first oil field was in Pennsylvania, and in 1855, I think. And the first oil field in India was in Digboy, Assam, almost same time, 1957 or so. So we are using oil since that time. Coal had already started coming into the picture. Gas came much later in the 21st century, 20th century. So coal, oil, and natural gas displaced biomass. Then after the Second World War, the nuclear energy came into picture, and at that time, we thought that will solve all our problems. But unfortunately, it has not happened for various geopolitical reasons. Large hydro has been our savior all over the world, especially from the environmental point of view. Environment meaning atmosphere point of view, but it has its own detractors in terms of large hydro effects on the nearby ground, the villagers around that place, and occasional floods and things like that, and how it affects the life of people around. Certain negative aspects, but even today that's considered as one of the best renewable energy source. And then this renewable energy, solar, wind, biomass has started coming into the picture in this century. Last century, in the almost, I would say, 60s or 70s. And new fuels like hydrogen and biofuels also came into picture in the 1970s. This biofuel, which we are going to talk about today, actually the biggest user of that today is Brazil, which started it in 1970s itself. We used to call it gasohol at that time. And today they have 45-50% of their transport fuel taken care of by these gasohols. So we started with biomass, went to fossil fuels. Now we are coming back at least to renewable energy, which are all natural energies. The sun, the wind, the earth, the moon, and the biomass, they are going to give us the energy. So biomass and biofuels are emerging again for energy security. This is extremely important. Last century was one of the limitless exploitation of global energy resources by a few Western industrially developed countries for unsustainable lifestyles, even today, leading to present global climate crisis. Why am I saying this? I want all of us to know that India has not contributed significantly at all to the global climate crisis. It is the Western industrialist developed countries which have done it, but they are putting a lot of pressure on us to go towards to stop the fossil fuels, which are they're doing it all over the world, but especially on us. I will give you some statistics about it. But this 21st century, we have already realized, thank God, we have realized that this fossil fuel based carbon dioxide, methane, nitrous oxide, they are very bad for the environment, and also water vapor. Actually, H2O is a greenhouse gas actually, but because it is there, our temperatures are we are able to live on the earth. So this century is going to be one of energy transformation. It's a very important century for the world and for all the countries. And therefore, the participants today, you are all in the initial stages of energy transition. We are now, Dr. Kanagwal used this term, there is a big term, energy transition from fossil-based energy to low carbon energy scenario, if not zero carbon, at least low carbon. So energy transition has started. How long it will take is one question that we should ask. So we are now declaring mid 2050, 2060, 2070 as zero net carbon, not zero carbon. We are still talking about zero net carbon. That means in 2050, 60, 70, we will be emitting carbon dioxide for various reasons. So it's not going to go away completely, but we should reduce it as much as possible. Now, when we accept that energy transition is happening, which is true globally, important three questions have to be asked. What is the energy transition time? From full fossil energy to full renewable. I would like to say that more than full renewable, carbon-free situation. How long it will take? And for that, what is the energy technology mix? We always talk about energy mix, but you should also add the term technology because each fuel can be used in different ways. What is that right way, right process, right technology for each fuel is also extremely important. And what is the mix of all this? And it should be sustainable. This is a very tall order for a society which has grown up on carbon-based fossil fuels and increased the standard of living, especially in the Western countries, to suddenly stop fossil fuel will be extremely difficult. So, what is the mix? Is it sustainable? Is a big question. Now, we have agreed to do certain things for carbon neutral, net zero, net zero carbon by 2050, 60, or 70. What is the cost? It's very nice to say that we should, things are happening, I mean, negative things, but we should, the whole world should transit to a carbon-free technology scenario, but what is the money involved? So these three questions are very important, ladies and gentlemen. Time required for transition, the cost required for transition, and what is that mix that either globally, all the world, all the countries will have, at least individual countries must have their own sustainable energy technology mix, which we don't know still, because it's also a dynamic thing. This mix is a dynamic thing. What's most important and what will really control our energy mix is energy security. Energy security is extremely important for each country. So each country will have to take its own time, its own energy technology mix, and cost whatever that is required. So individual countries should be able to do it, because finally global warming is happening, but I have to take care of my society. Everybody has to get enough energy. So energy security is extremely important. It has always been important. Today, when we are talking about revolution occurring, this is extremely important. And that's why, our government has gone into Atmanirbharta and all that. But my point again here is biomass, biofuels are extremely important component of the overall sustainable energy mix, which is dynamic, which will change with time. This mix will change with time, 2020 to 2030, 2030 to 2040, 2040 to 2050. And India has agreed for 2070 as the carbon neutral thing. Actually, at this point in time, it's difficult to predict what that mix will be, but one can have an idea of that. So energy security is important. It is a general term. Here I would like to say, what is ideal energy security? Meeting the total energy needs of a society using only indigenous energy resources. That's where solar and wind and biomass and hydro come into picture, and indigenous technologies. We have to develop technologies for our sources. The moment we depend on other countries for the technology, even though we have the source, we import the technology, our energy security reduces. And that's happening today. We have sun, but we are importing panels from China. 85% of our panels come from China. That's not a good energy security indicator at all. We should be developing the cells and the panels for our own use. The sun is there. Nobody can stop us from using our sun. I don't have to import sun or wind or biomass. And it should be funded indigenously. So big companies are required and the government is required to fund these things. That will be ideal situation. Any dependence on a foreign country for resource, technology and finance leads to energy insecurity. Today we are energy insecure. You know that very clearly. Today if China says, I will not send you the panels or you have to pay more, we're in trouble. If the oil bearing companies say, look, you have to pay more, $120 a barrel, we're in trouble. America is our friend, but it stopped us from importing oil from Iran. But now America is giving us oil and gas through the fracking, but at a higher cost. So whenever we import the fuel or the technology or get foreign assistance in terms of finance, there is no security. Now, ideal energy security is not possible. I'm defining that. So how much energy security we can get with whatever, in a very practical sense, is something which the country has to decide. Making the energy security index as high as possible in a dynamic situation. This is really practically possible, or pragmatic energy security. If we have to import, yes, we may have to import from friendly countries where it's reliable supplies are there. And all these things change with geopolitics. That's what you find. Energy is completely controlled by geopolitics. What the research we do and the technology we develop is one small part of that energy security. Really, geopolitical situations, policies of various countries, they really control this energy security. But being aware of that, if we can use more and more of our energy resources, our technologies developed by us, that will add a lot more to our real energy security. Briefly, you know, there are several sectors of energy: agriculture, transport, industry, residential, commercial, and power. This is how the government of India has divided, and we discuss in these terms. Earlier, we used to say residences and commercial, mostly electricity and fuels, used by them. But today, a new issue has come up: the energy that goes into buildings, these residential buildings, commercial buildings, is a huge amount of energy that's going in, which causes indirectly the environmental pollution. So one could add that as a separate building sector, but I've taken in that. In this, where will our renewable energies come in, either in terms of electricity or heat or whatever? So we know the biofuels will help us in agriculture, definitely in transport. Industry needs it very badly. Residences are already using 70% or so of our total energy in the rural areas comes from forest biomass residues. I understand every day many women in villages go hunting for this fuel for their cooking and lighting purposes. And because of that, there are many health hazards. So our major energy source today is biomass. We should not look at only the cities and towns, but rural areas. Biomass is a big source today, and they burn it up. And you know what is happening near Delhi? All that stubble burning and all causing the environment. So these are problems which we should do. But how much biofuel and biomass will come into transport and power and agriculture? That's a very important aspect that changes with time. Coal, oil, gas, nuclear, nuclear and electricity, they're termed as commercial because they're sold in the market earlier times. But all other biomass, fuel wood, crop residues, industrial and agricultural byproducts, animal waste, animal power. I would like to share with my participants here. I've retired 7 years back. When I was young, in my small town in Karnataka, the fuels day to day, and we are middle class, was cow dung and fuel wood. These were two for main inputs, cow dung, and I used to go and buy myself. fuel wood and cow dung. And then kerosene came into picture for stoves, for making coffee and all that. LPG came much later. I'm talking about the 50s and 60s. Cow dung was a big thing in towns also. And of course, fuel wood. There will be fuel wood shops. We will go there and buy, I don't know, 5 rupees for 8 kgs or something and bring it in a cycle rickshaw. Things are changing today. And what are the renewable energy sources? Solar, wind, hydro, biomass, geothermal. I have put ocean with a question mark because 10 minutes, about 10, 15 years back, we were talking a lot about OTEC, about tidal and wave. Today, almost it has been given up. There was a wave plant, there was a OTEC plant being built near the Tamil Nadu coast, but we were not successful. So today, I can tell you, there is not much work going on in the ocean area from the energy point of view. Other things they are doing. So we have to depend upon solar, wind, hydro, biomass, geothermal. So thermal also, the potential is very little in most parts of the country. And some, Ladakh and all that, they are using it for heating purposes. But theoretically, we can say if you have this, you can generate electricity and all. So you can, as of now, you can leave ocean and geothermal out of our overall picture. Their contributions will be either zero or very small. So the real things we have is solar, wind, hydro, and biomass. Now I come to the second part of my talk. As I said, Dr. Kanagwal has given an excellent presentation with beautiful slides. By the way, I should compliment him. So here we go. Ladies and gentlemen, I'll talk a lot of numbers. Numbers are extremely important. It's qualitative statements like we require more energy, we require less energy, this should be economically viable. These are all very general statements. We should know really what are the numbers on energy so that finally numbers have to add up. The energy that we require in terms of number should add up in terms of energy that we can acquire from various sources. Numbers should match. Why I'm saying that? Simply saying stop all the fossil fuel and we'll all go to renewable is a very nice statement, and it can be done. Maybe what is the time required for this? And is it really practically viable at some point in time? These are real questions which only numbers will answer. So here I go. This estimated hydrocarbon, that is oil and oil equivalent, 42 million tons. It appears a very big number, but this is estimated. Recoverable are much, much smaller than this. Very small amount. Coal reserves are more than 200 billion tons, but I know about 115 billion tons are extractable. So we have 115 billion tons of coal, and we are mining today about 600 million tons. So they may last for more than 100 years if we want to do that. So coal resources are very high. I'm stressing on this point. Indigenous coal reserves are very high. We are being asked to stop all this because of the global warming, stop coal especially. You know what happened in Glasgow. But I want you to remember that we have indigenous coal resources for at least 100 years. And oil, not so much, but much lesser. Now, if you go into actual numbers, we produced 34 million tons in 2018-19, but we imported 226 million tons. We are paying $70 to $80 or $90 per barrel. We are importing 5 million barrels per day. It's a huge drain on our foreign exchange. We should all remember. Almost anywhere from $50 to $100 billion per year, depending upon the price of the barrel. We are paying from our exchequer. And today our foreign exchange is much better, $650 billion. But out of that, every year we are paying $50 to $100 billion. This is where biofuels can make an impact by partially replacing the oil imports with biofuel use, especially for transport. Natural gas is very, very small, 33 billion cubic meters production. LNG imports are 23 million tons. We import liquefied natural gas, regasify that in some ports, and then supply it. So natural gas we are using not very much. Petroleum products which come out of crude oil, diesel, petrol, LPG, petcoke, naphtha, 262 million tons. So this is what we require on an annual basis. Please understand, and the future is going to increase. The oil industry in India and also Middle East oil countries, and the oil institutes, of course, they talk about oil. They say our imports will increase from now on up to 2040. In spite of having biofuels, in spite of electric vehicles, depending upon their penetration, we will be importing oil and gas for at least 2-3 more decades. 2 decades definitely, up to 2040. So anything that can replace that, any renewable energy, that will be very great for India. We produced 620 million tons or so of coal, and we imported 150 million because the coal we have is very high ash, lower calorific value. So we imported, and there was a shortage. Even 1 month back, we imported coal, low ash coal from Indonesia and Australia, but they are very expensive. So while coal is there indigenously, it is high ash, so it's better we avoid that. We import coal, we pay, whenever we import, we pay foreign exchange. So for oil and gas and coal, and then nuclear fuel, we're importing nuclear fuel, by the way. So all important sources, if we import, there is no energy security, really, ideal energy security. Now, if we come to biomass, I understand 750 million tons all over the country was harvested. But the surplus biomass that is useful for us for combustion and gasification and fuel is only about 180 million tons. I would like to be corrected upon this. This is what we have, 180 million tons on an annual basis. That's not a small thing, but that's not a very big thing actually. So how to use this 180 million tons? I mean, that was 2 years back. Every year it changes. It may increase in the future, or we should make it increase. So that will become very important for us to increase the use of biomass and generate different fuels and chemicals out of it. Now, whenever we talk about our sustainability, we should look at what is the per capita consumption, whether it's energy, whether it is carbon dioxide, whether it's electricity. So very quickly, I will go through this. Primary energy means total energy, coal, oil, gas, renewable, everything. It always is given in terms of tons of oil equivalent. So at the top, you see total primary energy, primary consumption in India, about 810 million tons oil equivalent. So we put coal, oil, gas, renewable, everything. Primary energy is this. And this is going to increase at 4.2% per year up to 2040. So where is that additional energy coming from? Which source? Which technology? You can imagine if you go by 1 plus 0.04 to power 20, tremendous amount of energy required because our population is going to increase. We expect the government to give us more and more energy to increase our GDP and our standard of living. So our total energy requirement, I want all of you to kindly note these things, extremely high because we are still a emerging developing economy. West has developed and overdeveloped itself, so it can afford to reduce the energy use, but they are not going to reduce that. But how can we reduce or stop? Our energy requirements are going to go up. If you remember this, so understand these numbers, then you can see how gigantic this whole energy problem is for India associated with the environment. This environment is a new boundary condition on our usage, So it's a very tricky thing. I have to increase my energy consumption. We are not energy hungry like the West. We are energy needy. We need energy. The West is hungry for energy because their lifestyle they have to protect or rather maintain. So if you look at it, kindly look at this one number. India, 0.7 tons of oil equivalent per person per year. Look at the world average is 1.9. Look at all the other countries. Where are we? In terms of even primary energy consumption, we are nowhere. Compared to a big countries, we are nowhere. I want you to look at 3 numbers. This one, electricity and carbon dioxide. So this is some number you should remember. Now, energy mix today is the following. We generated, Dr. Kanagavel gave an updated version of this. So what I want you to look at is the mix already. We have today coal, oil is very little, biodiesel is used. Gas, unfortunately, it's stuck at about 25,000 megawatts for several years because we are not able to import natural gas and our domestic gas production has not gone substantially. Nuclear is stuck at 6780 for 8 years at least. And now they are saying that by 2031 we will increase it to 21,000 megawatt. Good if they do. Our total potential of nuclear is 62,000 megawatt, but we are not being allowed because of the situation internationally. We don't have so much fuel, nuclear fuel, and also activists, environmentalists are stopping us from using nuclear. If we start using nuclear, a lot of our CO2 problems will vanish, but we are not being allowed to do that. Hydro is a big thing, 45,000 megawatt, and renewables is extremely important. So in the last hardly 10 to 15 years, this has come up, this 24%. Dr. Kanaga will give a slightly higher version because of 2020 statistics he has taken. This is very important. Now, how much we can increase this in the future is very important. So this is the energy mix. And in renewable energy itself, if you see, solar and wind are the main contributors. Today, we have 103,000 megawatt. I have given you 94 here, 103,000 megawatt of renewable energy. Out of that, solar and wind almost come to 95, but biomass is very good. This is all power generation. 10%, 10,145 megawatt is a fantastic number. Especially, I'm comparing it with when 20 years back I was teaching all this like a theoretical thing. Today, biomass is one of the big things. But 10,000 megawatt out of 400,000 megawatt is still only 10%. This is installed capacity. Kindly make a difference between installed capacity and actual energy generated. This is extremely important. Now you see, suddenly today, this is today's situation, coal is giving us 74% of electricity. Installed capacity is important parameter, but finally this is what comes down. How much electricity each source is giving? Coal is giving 74%. And look at nuclear is stuck at 3%. Gas is stuck at 3%. We have not been able, because we don't have much and import is a problem. Oil, we don't use it for power generation really in a large scale. Look at renewables. This is a good number today. This was very small 10, 15 years back. So this is the electricity generation is a better number for you to understand and remember also. We have renewables 10% today. Why I'm emphasizing that point? In the recent Glasgow Accord, our government has committed to increase this 10% to 50%. Here, this number, 10 to 50% in 10 years. So we are committed to 500,000 megawatt of renewable, most of it from solar and wind. In 10 years, that is about 40,000 megawatt per year we have to put in. At what cost? About 6 crores per megawatt. This is a huge money that is required. I have read that $10 trillion are required in this 10 years for India. Where is this going to come from? We are only a $3 trillion economy, trying to make it to 5 trillion by 2030. But we have to put in trillions of dollars. Who is going to give us the money? We should give us the money, use our own money for energy security. But if we give all the money here, what will happen to the other development? So it's very nice to say that we want to increase our renewable energy. Look at the cost. But we have committed. So let us see what happens in the next 10 years. This 10% has to go to 50%. And then coal will decrease, obviously. This is extremely important number. Electricity is the important part of energy. So I want you to know. Look at the per capita. The per capita is the one right number to see. India is only 1,100, ladies and gentlemen. Today is 1,200 maybe. World average is 4,300. Today we are 1/3 of the world average. And even this 1,100 has come to us from fossil fuels. How do we replace all that fossil fuels with renewable in the next 20, 30, 40 years and still have this kind of per capita, higher per capita? If world average is 4,300, we should at least have 3,000, no, in about 20 years. I will leave it to you to calculate if we want to increase the per capita consumption to 3,000 units in 2040 also, how much extra energy is required? And the population is increasing. Increased population, increased aspirations for a higher lifestyle, increased GDP. Our GDP has to go up 10% per year. And that won't happen without energy. This is what at least the West has told us. So look at Canada. And they advise us on stopping fossil fuels. I know we should do it from the environmental point of view, but what is the real solution? Technology and finance and time is required. That is why Government of India has done a good thing by saying carbon neutral by 2070. The rest of the world is very unhappy. But that's a little bit more pragmatic. I really would like to see how many countries who have committed themselves to 2050, which is very fairly easy to commit myself. But is this going to happen? But when we commit ourselves, at least we say, okay, we'll work towards it. From that point of view, it is okay. But in 2040, if India is going to reach the peak of coal, 2040, how long it will take that peak coal in 2040? This is the Government of India number, 2040 peak coal in India. How long will it take to reduce it to zero and replace it with renewable? It's a gigantic, humongous, unbelievably tough task. But we have committed. India is the only country which has committed to renewable energy of such magnitude and also reduction of the CO2. So kindly remember this 1,100 units. All this is available in the web. You can go. Now, briefly, I'll go through biomass because other technologies experts will talk about it. So we now come down to biomass. That is the scenario I gave you from electricity and primary energy point of view. I'll talk about CO2 a little later. You know already, many of you know, the varieties of biomass available, jitropha, sugarcane, cow dung. I was using cow dung, as I told you, 40 years back at home. I have made cow dung cakes with my hands in some small village. Corn, rice husk. We used to use rice husk at home sometimes for bathroom heating, you know, or the water heating. Coconut shells, wheat straw, wood logs, crushed chips, you know, shredded, crushed, powdered, pulverized. There are different forms. These pellets, briquettes and pellets are extremely important. In Europe, this is the one they are using. So they get the biomass, crush it, add some materials to make it into a compact, mechanical compaction or chemical compaction. And the briquettes and the pellets that you see are what are used in Europe for home heating mostly. That's where biomass is used for. Europe requires a lot of home heating fuel now, right now in the winter. They do it with natural gas from Russia, of all the places, plus they add their own briquettes and pellets. So they're very much into, and Sweden has a lot of, Scandinavian countries have a lot of forests, so they're able to do it. So these are the varieties here, then the properties are given, we will not worry about it. But what we should know, one property which I have not given here is, the volatile matter is very high in biomass, 70 to 80%. And ash, except rice husk, is very low. We don't bother about ash at all, except for rice husk, which could be very high. So these are two very good properties that the biomass have. The applications are basically in power generation, industrial heat and power. Power generation, Government of India has said, the MNRE has said we have potential for 26,000 megawatt of biomass, including bagasse. This is a fantastic number. Although in the future it will be, this is a total potential. We have set up only 10,000 megawatts today. Industry is in big trouble now because of the Glasgow Accord. Most of their heat comes from coal, oil, gas, a little bit of biomass. They are being asked to completely change over to biomass, renewable energy in the next 10 to 30 years. So it's a big challenge. Many of you can suggest with consultancy with industry to suggest how they can reduce their coal, oil and gas. Transportation fuels, that's what biofuels are all about, ethanol and biodiesel and biogas, we'll see. And always manure is a big byproduct of all this biomass. It can be used in solid, liquid or gaseous. I will not go into the details of this conversion pathway. There are many ways depending on the type of a fuel. But what I'll just read out this biochemical processes, methodologies, thermochemical. The solid biomass is converted into either liquid or a gas. There are many different technologies. Anaerobic and aerobic digestion for biogas, fermentation for ethanol. These two are most important today, biogas and ethanol. And these plants are already operating. And then direct solid combustion, there are many methods. You can gasify biomass. It's already known. Biomass gasification is already known. And electrochemical. If you can generate, say, CH4 in a biogas plant, its methane comes out. You can directly send it to high temperature solid oxide fuel cells to generate electricity. A lot of work is going on in this area. Low temperature fuel cells cannot take it. It's only high temperature fuel cells because of carbon deposition. So this is a very good area where biomass can produce CO plus H2, which is called the producer gas, or you can produce biogas, which is CH4, 40 to 50%, and carbon dioxide. But finally, you see all of these solid, liquid, gaseous fuels which have carbon, they have to be combusted, they have to be burnt. CO2 will come out even from biomass. CO2 will come out from biomass. But then we have been trying to say that fuel biomass is carbon neutral because it absorbs whatever it is giving out, CO2 into the environment and combustion. It has already, it is giving out what it has absorbed during its growth. So whatever it has absorbed, it is giving out, therefore it is neutral. So that CO2 is not added down to the global warming thing, unfortunately. But it is an additional thing anyway. And not only that, sustainability is not simply that whatever CO2 the biomass has absorbed, it is giving out. There are so many other factors of sustainability of biomass or any other technology. I'll try to give you some information later. So these are the various technologies. The last one is mechanical extraction. This is where you get oils from certain solid fuels and then go in for transesterification to get biodiesel. So three fuels today much in use and being talked about is biogas. We have many plants of that in India. And ethanol, a lot of push is being given by the government of India and it's happening. And biodiesel, somehow not much push has occurred into it. It is still a small amount. These three are the main things. Biohydrogen, yeah, these are all good for research at this point in time. But if it can be done, it's good. Research can give us how to do some things and gives us fundamental ideas. But for that to be used, it has to be, technology has to be developed, process has to be developed, engineering has to be done. Finally, they have to be economically viable. If they're not economically viable, the government steps in for subsidies. So for energy security, all these are important. Subsidies are important. Government has to give subsidies. So this chart tells you different biofuels, biomass have different processes and technologies associated to give you different kinds of fuels. Biodiesel, methanol, biomethanol, bioalcohols, and biogas, but basically you have to burn them. But some of you, if you can develop a technology for using biogas and ethanol, methanol, using fuel cells, which is a very hot technology today, there's a great area for you to do research and develop, making the actual fuel cells. Recently, a week back, a fuel cell based bus has been inaugurated in Delhi. Earlier, one Tata company also has done it, but they imported the fuel cells. The moment you import the fuel cells, again, your energy security goes down. So some people can work on fuel cells, some people can work on biogas and liquid fuels, and then integrate them together to get a electricity generating technology. These are all challenges which the Indian scientists and technologists we have to take. Not always dependent on others, so that there is no energy security at that point. So there are four types of generations of biofuels, I understand. Generation 1 is based on food crops like corn, soya and sugar in this country. Today, in the last 10-15 years, we are talking about, is it really good to generate fuels from food? So should biomass be used as food or as fuel? This is called food versus fuel conflict. So all over the world, there are many people who are questioning it, but still many governments are supporting the conversion of corn, soya and maize and other food products into ethanol. Whether they are sustainable is the next question. When American government, which generates a lot of ethanol from corn, they bought a lot of corn from the Middle American countries, and the price of corn went up in Middle America. They said, we want it for food. This is a practical problem. How can you use this corn, which is my food, to generate fuel? But United States and some countries are doing it, including Brazil also, to the best of my knowledge. So this is called first generation. And today in India, this is being done. Sugar, sugar cane, sugar juice, all those things, excess sugar, excess bagasse comes from sugar. We are using that for either biogas or ethanol, bioethanol. And second generation is after this conflict of food and fuel, we are now talking about non-food crops. Basically wood, agricultural residues, 178 million tons, which I mentioned to you, forest waste, industrial waste, different kinds of oils come out as waste material that can be converted into diesel, and municipal solid waste, ethanol or biodiesel or whatever. So this is non-food crops as the raw stock. That's generation second. Generation 3 is very important. This is algae or algae, which are marine aquatic biomass, as they call. Tremendous amount of research is going on in this area. Today, the next two talks I see is about this by our own Dr. Premalata here and Dr. Pandit from IACT. So you will learn more about the technical aspects of this, technological, scientific aspects of that from her. But growing algae for carbon dioxide mitigation and as a fuel is a very important thing. I mean, not algae, from algae you get other fuels. Now the fourth type has come. These first three generations are naturally available generally. Fourth is, this is a big thing for you, the young participants, genetically engineered feedstock, artificially, genetically, the feedstock manufactured and converted to fuels by genomically synthesized microorganisms. I should really submit here that I'm not an expert on this. So I hope you understand what we are talking about. It is like that GM foods, genetically modified foods. The entire fuel itself can be genetically modified. That's a very great thing. I don't know when it will happen, but a lot of research is going on. So as far as India is concerned, we are in stage 1 and stage 2, generation 1, generation 2 in actual use, commercial. Generation 3, a lot of research is going on in this country, including NIT-Trichy, as I know. Tremendous amount of research and development is needed. These are all various processes, various technologies. For biodiesel, for example, you require fermentation, esterification and fermentation. For ethanol, fermentation is the process that is used. For diesel, after you extract the oil, you have to trans-esterification, where you remove the triglycerides in the crushed oil, remove that as glycerin, which is a byproduct, and then the purer, the remaining liquid is ethanol, but that also has to be purified later. Now, so one is cultivation of the fuel, then generating this liquid fuels from that. This is a big process, but we are doing it. So you see the fuels, various kinds of fuels are giving on the left side here. The second one is petrol, compressed natural gas, which we want to replace with compressed biogas. So CBG is a big thing. Up to 250 atmospheres, biogas coming from biomass. It's again mostly CH4. You compress it to 250 atmospheres, pack it up, package it in cylinders and supply. So CBG is a big fuel, compressed biogas today. Ethanol, gasoline will be replaced 10, 20, 30% by ethanol. And you can get all these from various raw stocks. The technologies developed are here. Many technologies are known. Any technology to be commercialized requires two things: economic support, economic viability, and policy support. So in biogas production, basically we have what is called as anaerobic digestion for getting CH4 plus CO2. 178 million tons feedstock available for this. This shows there is organic waste in industry. Municipal solid waste, industrial waste can generate up to 130 million tons of oil equivalent. This is tremendous amount, tremendous amount. 15% of the total energy demand, if we can replace it, that is about 809 million tons of oil equivalent is the primary energy consumption. If you can replace 15% of that with the biomass, bioenergy, it's fantastic. But again, we need R&D, we need technology development, we need finance, we need policies. Some of you would like to look into these things. Various kinds of generator technologies available. And today, how many biogas plants are there? Small scale means less than 25 meter cube per day. We have several millions of that. This started 40 years back, 30 years back at least. So about 4 to 5 million such plants are available, generating CH4 plus CO2. And every year we are adding 30, 45 thousands of such plants. So this is a very active, available commercial technology. Major feedstocks. Today, we are talking about sugar for ethanol. Okay, that's about biomass, biogas. I'm coming to ethanol. I'm sorry, I have to make that. Sugar is our main thing, and sugar bagasse. But how much is available? Look at the last column. Surplus sugar is available is only 60 lakh ton, and that is what we are using today. Only surplus we can use. But it is a food crop. It goes up and down depending upon this production. Then recently, Food Corporation of India has allowed this damaged rice, millions of tons actually, to be used for this purpose. So lakhs of tons, 300 lakh tons, 30 million tons is available for ethanol making. Earlier they were not allowing. This is not usable food. This is unusable food which is wasted in storage and all that. Maize is a big thing again. You see about 100 lakh, 10 million tons are available. So if we add up all this, 60 plus 10, 6 plus 10 plus 30, about 50 million tons are available of sugar, rice and maize for ethanol production. This is based on molasses and grain-based distilleries. They are giving us 800 to 900 crore liters every year. But what we require, this ethanol is in billions of liters actually. I will leave it at that. Look at the scenario. Government of India has said 10% addition, so that's called E10, 10% ethanol addition to petrol. But if you do that by 2025, it's already started, we are at 8%, I understand. If you, by 2025, you have to complete that, we require 445 crore liters. And if you want to add 20%, this is what our government has agreed to do, 20% addition by 2030, you require 921 crore liters. This has to be produced on a much, much larger scale. And if you want to go to E100, sometime, that's 100% ethanol, imagine the amount of biofuel that is necessary. Humongous amount, millions of tons are required, processing technology is required, then money, of course, is required. And we should not be importing these technologies. This can be done in India itself so that our energy security is high. So the major challenge for any biomass system is availability of sufficient feedstock on a sustainable basis for a long time. If you take the life of a plant for 25 years, you should have biomass for 25 years without any problem. The other things are minor problems. Biomass is the real availability of feedstock is a real big problem. We have to take care of that. Finally, the third one, biodiesel. I will not spend much time because while we are talking a lot about it, our real usage is very little today. It's very important, crushing, using this generation 2 fuels. But look at this use of cooking oil. This is a recent thing. Government of India has allowed cooking oil, which cannot be used further, which should not be used. It's collected from restaurants and all that. And this kind of 2021, you will see this is tons, 55,000 tons is available in the country. Non-edible industrial, 90,000 tons is available. Animal fats and lows, a little bit less. So using 154,000 tons, 1,000 metric tons, so 150,000, that's a big input. But the use of biodiesel is still very, very, very. See, this is how much is being produced and consumed. We are talking about millions of liters only, not billions, which is what is actually required by 2025. Millions. If you want to convert all the vehicles to 20% or 30% in the future, tremendous amount of ethanol. This just gives an idea of, I'm trying to give an idea. Crores, hundreds, rather billions of liters, thousands of crores of liters are required, but we are talking about 400, 500 crores only today. And what is the market penetration? This is important. Look at the right side, percentage. We want 5% diesel, biodiesel added to diesel. Today, as of 2021, that penetration is hardly, look at that, maximum 1.18%. There's nowhere near 5%. Ethanol is much better. We are at 8% penetration. But biodiesel at 0.18%? When will we go to 5%? So this is a very disappointing thing that biodiesel manufacture is not much. There's a lot of controversy about it. But added to that is that government of India has said they want to discourage diesel vehicles from 2025 or something. So if you want the industry to stop producing diesel vehicles, there will be no need of diesel at all. So people will not be encouraged to go for biodiesel. These are all practical problems. So it's very easy to say, we will do that with a lot of hope, sometimes wishful thinking. We should have ambitions. But what is the practical thing? So biofuels today, ethanol is a big thing which is going on. Biogas is a big thing. Biodiesel, much smaller. That you can see in this chart, last chart here from International Energy Agency. Various countries are given that light blue is ethanol and the other real blue is biodiesel. Look at India. Look at the other 4 countries. Biodiesel is substantial. Look at ASEAN countries, that is the Southeast Asian countries. Biodiesel, because they have a lot of biomass. So biodiesel is quite high. But look at India. I hope you are able to see that blue thing is extremely small, less than 1%. This is, I'm talking about 2024. So even the projections for biodiesel are not very high by the government of India. So that's how it is. So that is about biomass. I'm coming to the last part here. I'll take at least 15 more minutes, please. Please bear with me. Sustainable energy mix. So I talked about the energy scenario and about the biomass to the best of my ability. I'll tell you something in the next 20 minutes about this. First of all, you have to know what is sustainability. True sustainability is affordable 24/7 energy for all. That is the real thing. You can add at the most as environmental friendly as possible. So a sustainable energy system is not simply putting a biodiesel there or a bio something there or even solar. It should satisfy some criteria. Availability, I call it the 6A criterion: availability, accessibility, affordability, acceptability, assurability, and all inclusivity. Availability means you should have the source, technology, and finance. Simply having an idea is not enough. Where is the technology today? Where is the finance? Then affordability. Yes, without affordability, you cannot do anything. Today, we are saying 685,000 villages are electrified. That is a half truth. Electricity is available at every village today in the transformer part. But the local people are not able to buy the electricity because they don't have money. They cannot afford it. So today, ladies and gentlemen, take this number from me. 150 to 250 million people in India are not using electricity on a daily basis, even though it is accessible in the village according to the government of India. But then the government of India says we are power surplus. It's mind-boggling. How can we be power surplus when 250 million people don't use electricity at all? So acceptability. This is where the West is talking about environmental acceptability. That's the only thing they're worried about, environmental sustainability. But what about the other aspects, like every person getting electricity, energy? And we are not talking about 10,000, 15,000 like the West. We are only at 1,100 per person. We have to increase it to at least to 2,000, 3,000 for every citizen. Humongous requirement. For us, that is the sustainability. And it should be 24/7 available. Not 5 hours, 10 hours per day, which is happening everywhere. I forgot to tell you in the acceptability, political acceptability is important. That's what is happening in Glasgow today. The last one is all inclusivity. Every single Indian. Even now today, you and I are getting almost 2,000 units. If you remove the 250 million from the calculations, those who don't have electricity, you and I are getting 2,000, close to 1,800 units, not 1,100. That is, 1,100 is because the denominator is 1.4 billion. But if you remove 250 million people, we are not bad, 1,800 units. But the others also have to get it. We have to give power to them. So everybody must be involved in this. So a sustainability index, therefore, needs to be estimated for energy system on a life cycle basis. These two terms I'm introducing, life cycle basis. What we should be looking at, what the world should be looking at is not simply environmental sustainability of carbon dioxide, greenhouse gases. That's what West is interested, because their per capita electricity, as you've seen, is 6,000 to 15,000 units. They are very greedy about energy. Therefore, their lifestyles are so unsustainable. But we should be looking at really societal sustainability. The entire society must be benefited. Every single Indian and every single global citizen. Therefore, the most important societal sustainability factor for us is every Indian, without exception, getting reliable, assured, affordable energy, electricity and other forms of energy, 24/7 in reasonably adequate amount. What is that reasonably adequate amount is another matter. So I have thought about it. Sustainability is nothing but what in India we say dharma. Sustain is to support, to preserve, to protect for a long time. That's what sustain means, sustainability. It doesn't say only environment. So dharma is, it also comes from the root word dhr in Sanskrit. Dhr means support, preserve, sustain. So the real word for sustainability, English sustainability in our language and our culture is dharma. What is it? This is climate justice. Electricity justice. Everybody should get electricity. Everybody should have environmentally free environment, pollution-free environment to live. This is dharma. Everybody must be happy. Not only the Western countries should be happy and we should be suffering. We should be paying for them. No, that's not right at all. So what we are looking at is not just environmental dharma, but a samaj dharma, entire society, 1.4 billion people getting energy environmentally friendly way in an affordable way. Thank you. And now I'm going to the sustainability part a little bit. In the Paris Climate Accord and in Glasgow, we have committed ourselves to this. Briefly, 50% of our energy will come from renewable sources by 2030. That's why we are going for 500,000 megawatt. The most important outcome of that place, Glasgow, last month was India had refused to declare a date for carbon neutrality. Now they have declared 2070, which is very pragmatic. It is maybe possible, but really 50 years from now or 30 years from now, what is going to happen globally, we don't know. Just because Germany says 2050 or America says 2050, this is what India argued. Look, 2050 may be okay for you, not for me. So don't have a common date of carbon neutrality globally. No. You let us decide about it and you help us in doing that. How do you help? How does the West help? Give us finance and give us technology. Because we are not in a position to now develop the technology and then implement. This 10 years, ladies and gentlemen, 2030, extremely crucial from many points of view, especially energy and environment. If we are not able to substantially reach these goals by 2030, beyond that, what happens? It will just not be possible. Now, a national hydrogen mission has been announced. According to me, this is good. All this is ambitious. Good. How much are we going to achieve is always a question. We should put in everything that we have. And then compressed. Now you see from fuels point, biofuels, 15 million tons production capacity of compressed biogas. This is a very good commitment. And then 20% ethanol blend by 2025. So Government of India policy is very clear. They did not say biodiesel, by the way. Please see that. They have talked about biogas and ethanol. Very realistically, they have not talked about biodiesel. I think that may have a little lesser priority. I may be wrong in this, but the commitments that we have given at the global level is for ethanol and compressed biogas. So anything that you can do to make these two sustainable will be fantastic. Now, this environment sustainability is only because of carbon dioxide, right? But who is emitting carbon dioxide to the environment? Look at this. Total CO2 emissions in the world is 40 billion tons about 3 years back. What is India's contribution? 2.3. Now it's about 3.5. It is the least of all these big countries that we are talking about. Germany and Australia. Australia is very surprising that it has 0.388, but because the population is very low, some 60-70 million. Germany is also very less, but Germany has gone into solar and wind in a big way. So that is okay. But look at China. Look at European Union, which advises us a lot of things, which teaches us. And look at USA. So it's all very nice for the West to tell us about these things. But is it possible for India? It's possible, provided we get money, time, and technology. So total, but look at the per capita. This is really something. India is the lowest per capita CO2. Please understand the two earlier slides. Per capita electricity consumption, 1,200 units, lowest among these countries. Per capita primary energy consumption is only 0.7 ton oil, which is the lowest. And per capita CO2 emissions, India is again the lowest, 1.7. Now they are telling us to simply still reduce it further. How is it possible? Even if it's possible, give us the technology and the money and the time. Therefore, Modi has taken time up to 2070 for zero, net zero, not carbon zero, which is very wise. And the entire Glasgow conference was not on technology. He's asking for money and time. This CO2 per GDP is what is discussed in all these conferences. You will see on the left side, India is very high. The West chose this so that they can, this way of, suppose they have chosen CO2 per capita to discuss, they would be at a disadvantage. But they chose this, I will not say intentionally, there are some reasons, so that India, China can be pressurized into stopping coal. Look at this. So, per unit of GDP, obviously these are all high GDP countries, Germany, Australia, USA, world. These are all, not world, I mean, the other countries are highly, GDP is very high, therefore their CO2 per GDP is very small. But India, GDP is very low. We are talking about 7%, 6%. Our CO2s are not really high, but CO2 per GDP is high. So in Glasgow, we have committed ourselves to reduce this 0.9, by 30 to 40% or even 50% in the next 10 years. So we are one country which have actually committed to reducing carbon dioxide with numbers we have given. Others have not given like this. India is extremely serious and sincere in doing all these things, increasing renewable energy, controlling CO2, and we are showing that in action. But money is going to be a problem, technology is going to be a problem. At least technology, we scientists, you researchers can do something about it, but money, 10, 20 trillion dollars in the next 30, 40 years, where is it going to come from? This is a point here, carbon budget. How much CO2 can we put into the environment? This is also a matter of contention. Whatever amount that the atmosphere can take carbon dioxide to limit 1.5 degrees or to 2 degrees, 80% of that has been already gone, has been utilized by the West. Only 20% is available. From now on, therefore, they are putting pressure on India. Oh, you have to reduce coal, also China, so that that carbon budget they can use. India is asking very correctly, that's not climate justice. We are still a developing country. I have to provide energy to my people. So give me more budget. This is where we got stuck in Glasgow. We got stuck in Glasgow on two accounts, finance and this budget. Look at this. 40 billion tons per year is what we are emitting. According to this, that 40, after that, if you go on adding CO2, the temperatures will go beyond 2 degrees. That's what it means. In the next 30 years or even in the next 6 years, we are not even able to predict properly how long it will take to reach this CO2 mature situation. So many things are not definite, but it's definite that China and India should reduce coal, oil, gas. This is very, very not justified. It is not dharma, actually. It is not global dharma, if I can say that. Okay. So last part, I'll try to do this. Is biomass sustainable? This is a thing that we should ask. Is sustainability, does it simply mean that CO2 that it takes in by growth, it leaves out, so it is CO2 neutral? Is that sustainability? Maybe from an environmental sustainability point of view, maybe, but even that is not true, because When you want to look at the fuel use, you have to look at the lifetime from start to finish, from birth to death of a fuel. During the process, how much carbon dioxide is generated, how much energy is consumed, how much water is consumed, what are the policies, what about the biodiversity, all of that you should see. For biomass sustainability, you have to take care of land use. This is extremely important, land use. More, this land also emits carbon dioxide when you convert, from energy crops to other crops. Then water, how much water is needed for biofuels? What is the efficiency of this conversion? How about the waste? How do you manage the waste? What is the cost of all this? What are the limitations? Can we do everything by renewable? There are some limitations. Then what are the social impacts? How much is available? All this goes into sustainability. It's not simply the CO2. CO2 here comes, I put it under environment and the social impact, but we should consider all other aspects. Therefore, the sustainability changes. There are several stages of biofuel use, as you can see. Cultivation, harvesting, processing, transport to manufacturing plant itself, product storage and transport to dispensing stations, product utilization. So from cultivation to product utilization, these are the steps. Look, stages. See what is all involved. You require land, water, fertilizer, pesticides, energy, social impact, greenhouse gases like CO2, N2O. N2O comes from the fertilizers. And there are pesticides. Cleaning is necessary. For all this, energy is necessary. What energy is being used? Fossil energy is being used. That is generating CO2. That CO2 generated by fossil energy for you to cultivate biomass should be added to biomass. Otherwise, it's not simply what it has absorbed and then given out. How much carbon dioxide has been emitted by the energy used in even cultivating? I hope I'm communicating here, ladies and gentlemen. And how much energy itself has gone into it. Then harvesting, how much, again, energy, water and GHG. Processing, at every step you see energy is involved. That energy, if it is fossil energy, it is generating carbon dioxide. It requires water. It creates biodiversity. Chemicals are used, fertilizers are used. So from cultivation to product utilization, what is the efficiency? What is the environmental impact? What is the economic impact? Because you have to plan for all the cost of all this, land, water, fertilizers, all that cost. So you have to come with a levelized cost of electricity or energy for these stages in any biofuel. And what is the social impact? When you take all this into consideration, the sustainability is entirely different. It may be or may not be sustainable. Any energy source, I'm not talking about biomass. We should be doing this for solar, wind and everything. And we have done something on that. So what are the indices for that? Two important indices for sustainability for biomass, I'll tell you. Overall, GHG emissions per unit of energy. During this complete cycle from cultivation to utilization, how much CO2, CH4, N2O have been emitted per unit of energy that you are able to use. If this is higher than the use of fossil fuel, then it is not sustainable. This number must be less than when you use fossil energy. So it's all compared with fossil energy. If the GHG emissions on a life cycle basis is higher for biomass compared to fossil, then it's not sustainable. Same thing with conversion efficiency. What is the efficiency loss from converting from seed, whatever biomass, to final product? Is it 10%, 90%, 100%? Then EROI, energy return on investment. I told you we put a lot of energy into biofuel at various stages. We are putting in energy, but it gives us only a certain amount of energy. Ethanol, when you burn, it will give some certain amount of energy. But you are putting a lot of energy. So ethanol gives you 100 units of energy, let us say, when it is used. But if you are putting 400 units of energy to cultivate it, harvest it, process it, then it is not sustainable. You are getting only 100 units of energy from ethanol, as an example. By putting 400 units of energy, how is it sustainable? So how much energy comes as a return on investment? If I have put in 400 units of energy into the manufacture of biomass and all the processes, I should get more than 400 units of energy from ethanol or any fuel. Twice, thrice or four times. Otherwise, it is not sustainable. So it should be energy sustainable, it should be environmentally sustainable, it should be cost sustainable. All these aspects go into the sustainability and effect on biodiversity. If I go on planting crops, what will happen to the diversity? And it has been studied very well in South America. It is destroying. Some aspects are getting destroyed. What is the social impact? Positive thing, how much employment it will generate. Is it acceptable to the people that this particular fuel is being gasified, combusted, or converted into ethanol? And what is their perception? Today, the perception of nuclear, for example, it is very safe. France has 80% nuclear, but we say, no, it's not safe. This is perception. It's a social thing. That depends on the government, the policies, the media, and how we can be brainwashed, basically. In biomass, one of the major things is land use, reuse effects that has to be looked at. When all these things are combined, ladies and gentlemen, we get an overall sustainability index. We should get. Very few people have done this on biofuel. A lot of other work has gone on in the first two that I have shown. You can go to the literature and find out. Now I see I have hardly 5 minutes or slightly left. So I'm saying that CO2 is not the only thing to say about sustainability. There are so many other factors which we call as criteria. In fact, some countries already have a lot of opposition to this in Brazil and UK, but because it is necessary, governments are giving money. Brazil is 47% ethanol, I think. So in India, there is an urgent necessity to carry out biofuel sustainability studies on a life cycle basis, that is from birth to death, to get to know whether this biomass use is sustainable. By the way, there is no single energy source that is sustainable. What has to be made sustainable is its use. So I always say sustainability of energy use rather than a sustainable energy source. Even coal, I can make it sustainable if I can absorb the carbon dioxide. Anything can be made sustainable if it's economically possible. So we have to go through a life cycle assessment for all biofuels with various criteria, as I mentioned. What I would like to show you, I myself have not done a life cycle analysis of biofuels, but I have done, my students have done life cycle analysis and sustainability index for coal with respect to other energy systems, coal, oil, gas, nuclear, and biomass. We took a 600 megawatt system and tried to find out what is the most sustainable system source for this. I've given you the procedure here, but I will not bother you. It is based on life cycle assessment and AHP, that is called the analytic hierarchy process, and TOPSIS is TOPSIS means technique for order of preference by similarity to ideal situation. This is a program. These two programs are developed by management people. If you go to the management department, they will easily give you this. I think some of you can try how to get the sustainability index for biofuels. Without going into the details, I'll give you my results that we got. I took for various fuels these criteria, as you can see here: resource, energy, environment, economic, social dimensions, they are called. In each dimensions, I took certain indicators that's left to me. So I have here 14 criteria. I get numbers from the literature about land usage per acre per megawatt, water consumption, efficiency, capacity factor, CO2, capital cost, so many things. That is under my control. I then put all these things together through those software programs, AHP and TOPSIS, to get an index, a number less than 1. It should be less than 1. This is my final graph of that. This is a sustainability analysis of coal relative to other systems, including biomass, as you see. The 600 megawatt power plant, and have given equal weightage. Giving weightage is extremely important in this. If you give equal weightage to all this criteria up to 1, this is the result. What it says is very, very important. Of all these things, you see, biomass 0.44, it is the least sustainable from power generation point of view. I have not taken biofuels here. The major problem why this has occurred is it is not available continuously on a large scale for a 600 megawatt unit for 25 years. A plant life is 25 years. So biomass is not available for 25 years for my 600 megawatt unit. Immediately I give it a low weightage it is giving 0.44. But look at nuclear. It is fantastic nuclear. It is high, 0.65. You know why? Carbon dioxide is 0. So that shows the effect of that. And look at solar and wind. It is not one. Still, it is not one. There are problems with solar and wind in terms of availability. I call solar the sun as a 9 to 5 guest. He's available only from 9 to 5. So he's really not sustainable on a 24/7 basis. Why do we call it sustainable? Wind is a 4-month guest. July, August, September, October. So sun and wind together, they are available to you only 1/3 of the year, 4 months, really. 8 hours a day if you take, and 4 months in a year for wind. Only 1/3 of the year is available. What do you do the rest of the time, 9 months? You have to make them sustainable. They are not sustainable by themselves. To make them sustainable, how? Choose different fuels or same fuel, different products, and get a number like this. That will really tell you, considering all other criteria, whatever criteria you want to consider, whether a particular fuel is sustainable for over a period of 20-25 years for that particular application, ethanol or biogas. So we give 25 years as approximately plant time. And for those 25 years, how much energy we are going to get out of it, how much carbon dioxide we are going to put back into the system because of all the cultivation, harvesting, all that we are doing. It is not simply taking the carbon dioxide absorbed by the leaves, trees and giving it back. All this CO2 has to be added. All this energy has to be added. All this water has to be added. Only then you will get the true sustainability index, as I have got here, these numbers less than 1. Now, what I have done here is, for different systems, coal, gas turbine, nuclear, hydro, I have taken 5 dimensions. On the right side, you can see resource, energy, environment. I want to see how each system will react to a change in resource, energy individually. So for each plant, I have got, you see, 5 columns in different colors. Each one of them tells me, for example, coal, the blue one is resource. So resource sustainability is very high because it's indigenous. Then 2B, that is orange thing, is energy. Our Indian coal is very low energy, so that's small. Then you go to environment, it is causing a lot of CO2. So that gray thing gives you that idea. And economic, there is no problem at all. Social is very low because it affects the health of the people. Similarly, for each system, if you go to nuclear, you see many of these things are high. Gray one is environmentally, it is the best. Solar, environmentally, is the best. Wind, it is very good. And even hydro is very good. You see all those gray columns, they say environmentally it is good. But where solar is not good is that orange thing that you see here, which is energy, because its capacity factor is only 0.22 compared to coal or oil or gas of 0.75 to 8. So 1000 megawatt of fossil plant, if you want to replace, you have to put in 3000 to 4000 megawatt of renewable energy, 4 times, because the capacity factor is 1/4. So it's not simply 500,000 megawatt of solar, that is equivalent to only about 150,000 megawatt of fossil fuel or even nuclear. So this analysis will give you tremendous insight into individual criteria and then give you an index which you can use as you like, especially policy makers. So last 2 analysis, as mentioned above, sustainability analysis on the basis of LCA must be carried out for every biofuel system to estimate their sustainability. Identify the benefits and drawbacks of each system. Like biodiesel may not be sustainable today. Identify R&D gaps for our further R&D and required policy support that can come from the government. All this is practically viable. So now, the role of sustainable use of biomass. I am not saying sustainable biomass. Sustainable use of biomass, crucial in transportation and industrial heat supply in any future sustainable energy mix. This is the title of my talk. My conclusion is, you use biomass sustainably based on a sustainability analysis, and generally it will be applicable in transportation, ethanol and biodiesel, and industrial heat supply, including biogas, is all very good for in a sustainable energy mix. It is a very crucial role to play, because that will decrease our foreign exchange output and energy security will be improved. Its role will be relatively minor in power generation because we have only 26,000 megawatt capacity, and in the future it will go to some 2,000 megawatt. So this capacity is very limited from that point of view. There is no one sustainable energy source. Sustainable use of all available sources is actually what is important. A judicious, sustainable energy mix crucial for energy security, including all energy resources. I will not even remove the fossil for India and China. Fossil, renewable, new like hydrogen, biofuel, everything has to come together in a sustainable fashion, taking many criteria into consideration, as I mentioned. And this sustainable energy mix will change with time. Next 10 years, it will be something, 20 years, it will be something, 30 years. It's not ironclad. So one has to do continuous analysis of this to get a proper energy mix. And there are tremendous amount of challenges, technology, process, social impact, finance, practicality of putting in so much of additional. That's a big challenge. Last remark, life cycle assessment based sustainability analysis is a must for every biomass energy system on a regional and fuel basis. Simply saying it is sustainable, a source is sustainable, is not a sustainable statement at all. Thank you all very much. Thanks to the organizers. Thanks to all the participants. I apologize for taking about 15 minutes extra. Thank you all very much.
On behalf of the organizing committee, I sincerely thank you for that structured, stimulating, informative, insightful, and interesting lecture. As usual, you passionately delivered it with a lot of important numbers. I'm sure all the participants had a good exposure to the energy scenario in general and the role of biomass in the sustainable future energy mix in particular. Thank you once again, sir, for your valuable time and an interesting lecture.